Hello everyone, in this video we are going to solve more absolute value equations. So what's different about this video compared to the last one, which I'll drop a link below for reference, what's different here is that we're going to have some combination of terms in between the absolute value symbols. So to solve an equation in this form, and let's just say capital A here represents a variable expression. It could be as many as 2 or 3 terms, depending on what's going on in here. B is going to be positive. So remember, this has to be greater than 0. If we ever have a negative in this step, we're going to have no solution, and I'll show you an example of that in just a few moments. So what we're going to have here is the variable expression equal to positive whatever number this is, and then we're also going to have it equal to the negative of it. Because remember, what's going to be over here is just a number, and it has to be a positive number. When that's the case, we'll set it equal to the positive and the negative of whatever number that is. Let's look at a few examples. Here I've got the absolute value of 2p plus 5 equal to 11. So I have no other operations outside of my absolute values, nothing over here. So we're going to write our two equations and solve. Remember that what stays in the absolute value stays the same. What's going to change is the second equation that we write, because this is the first one. Second one will be right over here. And we're writing the negative of this. And then we would solve this regularly like we would solve linear equations. I have 2p equal to 6. Dividing this out gives me positive 3. And then over here, same steps. Negative 11 minus 5 is negative 16. P for my final answer is going to be negative 8 once I divide by 2. And we have two distinct solutions. We have two different solutions, and that is okay. And that's going to happen when you're working out these absolute value equations where you have a variable expression in your absolute value signs here. Keep whatever is in between the absolute value the same. What's changing is whatever it's equal to. You're going to keep the positive, and then you're also going to write the negative. Let's look at one more. Here I have 2 times the absolute value of d plus 3 equal to 8. I got to do one step first before I write my two equations. Dividing by 2 cancels out that coefficient out front. The absolute value of d plus 3 is now equal to 8 divided by 2, or positive 4. From here, I write my two equations. I have d plus 3 equal to positive 4, and then d plus 3 equal to negative 4. Those are my two equations. Subtract 3, and I have d equal to 4 minus 3, or positive 1. Take away 3 here, and I have d equal to negative 7. So here is the rundown for when you have an absolute value expression equal to a positive number. So what would happen if we ever had an instance where what was in the absolute value, those absolute value symbols, what if that was equal to something that would be negative? If that's the case, then we're going to have no solution. And here's an example of what that looks like. This is just a brief example here. If I divide by negative 3 first, I've got y minus 3, the absolute value of y minus 3, equal to negative 3. The problem with this is that, remember, the absolute value cannot be negative. So here we're going to have what's called no solution. You cannot have the absolute value of a number, or in this case, some expression, equal to a negative number. Because remember, we treat absolute value like a distance, and distance is never negative. So this would be a special case where we have no solution. Thank you so much for watching, and I will see you later.